Hello, in this lesson, can we learn about the center of rotation, about the origin? But before we start understanding the logic, can we learn some properties about the Cartesian plane here? So, this of course is just a graph where we have the x-axis and the y-axis. And as you can see, both the x and y-axis have a scale. Each of them has a scale. And then in this graph, this part here, we call it the first quadrant. Then this one, we call it the second quadrant. This one, we call it the third quadrant. And this one is the fourth quadrant. Now, with that knowledge, I want to show you something else here. When I say rotate clockwise, this is what I mean. You rotate like this. This is clockwise. And when I say anticlockwise, this is what I mean. You rotate like this. And from there, I can remove all these ones. And then let me also remove these. From there, we can start the scale of each of the quadrants. So, in the first quadrant, both the x and the y axis scales are positive, as you can see. Then, in the second quadrant, the y-axis scale is positive, but the x-axis scale is negative. Then, in the third quadrant, both x and y-axis scales are negative. And then in the fourth quadrant, the y-axis scale is negative, but the x-axis scale is positive. Then from there, the next thing is when we talk about center of rotation from the origin 0, 0, it means where the x and the y-axis meet at the point 0, 0 here. The center of rotation can change, but at least for now, ours will remain to be from the origin, which is where the coordinate of x is 0 and the coordinate of y is also 0. So, with that knowledge, we can start some rotation questions here, and we see what happens. So, the first rule of rotation about the origin is that if you are told to rotate 9 degrees, a figure 9 degrees clockwise about the origin, what happens is the x and the y-axis coordinates do interchange. For example, if we have xy, now it changes to yx, but now the x is negative. You put a negative on the x. So can we apply this in a question so you see what I mean? So you're told a triangle has vertices A is 2, 1, B is 5, 1, and C is 3, 4, and then rotate the triangle MBC 9 by 9 degrees clockwise above the origin, and then write the new coordinates of the rotated triangle. And the first step, let me copy these original coordinates in my board. So now we have the original coordinates to get the new coordinates of the rotated triangle. In our case, it is a triangle. We need to apply this rule here. And as you can see, we have x and y. This xy, of course, it means the x coordinates of each of these points. So that is the x coordinate for A, for B, and then for C. And this is the y coordinate for A, for B, and for C. Then from there, the next step you need to do is to write now the new rotated coordinates, where we can start with just interchanging them. Where we have, if it was xy, now it changes to yx. So here, xy, now y comes here and x comes here. So in A, it will be now y will start and then x will finish like this. 1, 2. Then we go to B. We do the same. Y starts, then x finishes, and then we go to C, where y of course starts and x finishes. But you see, there is something more here, where all the values which we interchanged now on this part, which are here now, they should be negative. So I'll put a negative there, a negative here, and a negative here. And now those become the new coordinates of the rotated triangle from the origin 9 degrees clockwise. And then we also told, so we have actually answered this part, right? The coordinates of the rotated triangle. And then we are also told to plot the two. So we can come here and plot the two and see if actually what is happening. And we already have our center of rotation here still blinking. We can start with the original triangle we plotted. So it was A21. So it comes here on the X is 2, then on the Y is 1, like that. Then B is 5, 1, 5, and 1 somewhere there. And then the last one is 3, 4. So 3 and 4 somewhere there. And that becomes our original triangle. But then the rotated one, we can rotate 9 degrees clockwise, and we have our new coordinates, which is 1, -2. So we come to the x-axis is 1, then -2 somewhere there. Then we go to the second one, which is 1, -5. Then we have 1, -5 somewhere there. And then the last one is 4, -3. So 4, then -3 somewhere there. And now you have rotated that finger 9 degrees clockwise. So from there, we can start. As you can see, the points, this finger looks like it's flipped. And that's the whole logic of rotation. So can we try another example? So in this example 2, you are taught to rotate the same triangle from the origin, of course, 180 degrees. So what this means is from here to here we were rotating 9 degrees. So to rotate 180 degrees, then it means it should move, the original triangle should move from here to here, which is 9 degrees, then to here, which is 180 degrees. So the next step is study this rule well about 180 degrees from the origin. You'll note that, well, x and y do not change, they just remain the same, but now they become negative. All of them become negative. And the reason for this is because in the third quadrant, as we said this is the first, second, and third. In the third quadrant, where we are supposed now to rotate the figure, both the y-axis scale and the x-axis scale both are negative. And that's why you see now the rule changes to x and y being negative. So can we try this? Let me first copy this original coordinates. So we have our original coordinates, and we said 180 degrees clockwise, of course. The new A will have just the same coordinates, but now all of them being negative. So in our case, in A it will be -2, -1, because it is negative x, negative y. Then in B, it will be -5, -1. And then in C, it will be -3, -4, like this. And then now that we have the new coordinates of the new triangle, we can plot it in the Cartesian plane. And as usual, we start with our original triangle, where we do have 2, 1. And the center of rotation, of course, is still 0, 0. So we start with our original triangle, where we had 2, 1, like that. Then we go to the second one is 5, 1. Then 5, 1, and the third one is 3, 4, 3, and 4 somewhere there. And that's our original triangle. Then we rotate it to 9, then to 180, and we don't need to put it here, we just need to switch the mode here to 180. Then we plot our new coordinates. So our new coordinates are -2, -1, -2, -1 somewhere there. Then the second one is -5, -1, -5, -1 somewhere there. And the last one is -3, -4, -3, -4 somewhere there. And now we have rotated that triangle to 180 degrees clockwise above the origin. So, can we also try to rotate the same now to 70 degrees above the origin as well? So what happens if you rotate a triangle to 7 degrees clockwise or even 9 degrees, and clockwise is just the same thing, but let's just stick with rotating to 7 degrees clockwise. That rotation of 27 degrees clockwise, it changes now the variables to negative to yx, so xy becomes now yx, but now the y becomes negative. And the reason for this is very simple, because if you rotate to 70 degrees, first you note that from the first quadrant, the second, the third, this is 180. So 270 will be in the second quadrant if we are going clockwise like this here. And as usual in this second quadrant, the y-axis scale is positive and the x-axis scale is negative. So, if we come to this question here, as you can see, we have changed xy to yx. So the coordinates of course, of x now will be the coordinates of y, and the coordinates of y will be the coordinates of x. So from there, you see now this y here occupies now the coordinates of x, not y anymore. But the x scale in the second quadrant is negative, and that's why we are putting this negative here. So now with that knowledge, we can write the new coordinates of the rotated triangle, and then we try to plot them. Well, so can we apply this rule to get the new coordinates of A? Where we said, of course, we can first interchange here. So this is x, this is y, this is x, this is y, this is x, this is y. So now y starts, so it becomes 1, 2. Then for B becomes 1, 5. And then for C, now it becomes 4, 3. But we said everything that will occupy this space, of course, the first one, they must be negative, so we put negative in all of them like this. And then we can go back to our Cartesian plane and we start plotting them. So we start with the original triangle, which is we had 2, 1 somewhere there. Then the second one is 5, 1. We have 5, 1. And then I think we have 3, 4 somewhere there. That's the original triangle. And then we can now plot the rotated 1 to 7 degrees clockwise, which is negative 1, 2. So negative 1 here, then 2. These 2, 7 of them is the mode. Negative 1, 2, I think. Then we have negative 1, 5. Negative 1, 5 somewhere there, and then we have negative 4, 3, negative 4 and 3 somewhere there. As you can see, we have rotated that triangle to 7 degrees clockwise. So that's how we do rotation of fingers from the center of rotation, the origin, which is 0, 0. So if you have any question, you can ask me on the comment section. If there is a place you don't understand, you can tell me to clarify. And bye for now. Let us meet in the next lesson.